All right. Our next presenter is Bill Nichols. Bill Nichols is a principal member of the technical staff at the Software Engineering Institute. He conducts engineering research and software measurement. Thank you so much, Bill, for doing this. It's super appreciated.
Well, thank you. I'm really pleased to be here. Thank you for the invitation. My subject today is about automated continuous estimation for pipelines and factories. So I'll go into some details, but first, if I can get the right screen focus, just briefly, I am from the Software Engineering Institute. We are an FFRDC in Pittsburgh, Pennsylvania. So I'm a lifer. Well, I'm not exactly a lifer at Carnegie Mellon. I did my undergraduate and my PhD there. Around 15 years ago, I returned. And I returned because I wanted to see what else we could do in software engineering as we started to build bigger and better systems. And that got me involved in the world of software estimation and project and program tracking. So I'll talk about today are some of the challenges we have in the modern development environment with DevSecOps. Some of the issues as we scale the development up to multiple pipelines, even multiple organizations, how automating some of the measurement and analysis can help to resolve some of the issues that program management is happening. So as I go through that, I want to talk a little bit about a prototype that we've put together, some of the lessons learned and some conclusions and where we're going in the future with this. So I hope you find some of this interesting, and we will be looking for collaborators in the not too distant future to start rolling out some of these concepts and trying to understand some of the measurement and the engineering and science behind what the data can tell us. Now, let's talk a bit about the problem. Most of you probably remember Fred Brooks. He famously asked, how does a project get to be a year late? And it was a rhetorical question. The answer is 1 day at a time. Now, that brings us in the agile world. How do you know that you're slipping 1 day at a time? Do you have the information to see these 1 day slips? Because if you can't see these things more or less as they're happening, they sneak up on you. They sneak up on you, and all of a sudden, 1 day you find you're a couple of years behind. Don't let this happen to your program. But how? Well, how long does it take you to recognize an issue? What is the data lag? How long does it take to respond to user needs? How about a critical issue? If you have a critical issue like a vulnerability, how long does it take to get that patch into the field? How long does that take versus getting a real new capability or feature? How current is your data? Is the data you look at for your planning from today, or is this from last week or last month? Now, I ask that because you have some dichotomy here between those of us who have a lot of experience in the DoD world, where a lot of the work is being done at arm's length, and the more general industry, where you have companies with their closely held data and they can see this instantly. If you don't have direct access to all this data and you're getting these lags through contractual agreements, you have to be very careful about what you're asking for. Then we'll ask, how credible is your data? Is it accurate? Is it complete? Is it representative? How was it recorded? And do you have everything you need? Sometimes having inaccurate data or not quite the right data can be worse than having no data at all. Now, the thing is, program managers need answers. If you're the program manager on a complex modern agile program, you have to be able to answer questions like this. We have a new high priority. In our DoD world, it could be, we have to field some capability because the adversary has fielded something we didn't expect. We have to respond to something unexpected. How long is that going to take? What about this new priority capability? Well, it's already slipped twice. When am I really going to have it? No kidding, have it. What if I do something differently? How many more teams will it take to accelerate this capability to get into maybe 6, 12, or 18 months? This is a what-if scenario. Or why am I finding so many issues in the software during final test? These are issues the program managers need to answer, and they want to do this quantitatively. They don't want the wet finger in the air. They want to have some hard data. So what do you need to know? You need to know these so you know, are we going to finish on time? Are we going to have this capability when we really need it? Or in our DoD world, are we going to have this capability when the artillery range is ready? Are we going to have this capability in time so that we can start planning on training the submarine crew on the new equipment? These things really matter in our defense domain. Are we going to have enough money to finish? Do we have the budget allocation? How far along are we? Uh, when could we have it? Projections? What if we adjust priorities? Again, what ifs? Can we adjust priorities? Can we adjust staffing? What could we do? Data. So what we have been proposing and we've been working on for the last couple of years is how to extract better and more information automatically from the DevSecOps pipeline. This involves instrumenting the pipeline and the surrounding development infrastructure so that we can collect data. We can collect data that gives us answers to these questions. So it's not just data for the sake of data, it's data to answer specific questions about how far along are we? Where are we going? When will we be done? How much will it cost? What kind of staffing are we seeing? What kind of rates are we getting today? We want to understand what is the program status and make future projections. Now, there are a number of reasons for automating this. One of them is that you can collect collect the data and store it in more consistent forms. I won't, excuse me, I won't go into some of the issues we've had in the past where, pardon me, where data is being recorded by hand. We want to get, to the extent possible or at least reasonable, humans out of the loop. We don't want them doing things that they find to be redundant or non-value added to them. So there's an opportunity for the automation. The automation can be repeatable. It can be done consistently. It can be done with relatively low effort once it's set up. And if you set that up and you have proper analyses of these data, now you have the potential to have dashboards available in more or less real time. So you can get up in the morning, have your morning coffee, and see reports about where is your program. So I prepared a few lines to show some of the evolution in how we might be tracking program work in the past and now. And this is an illustration of what we might have been doing in some very basic earned value type of world. Earned value is a simple but primitive concept for tracking percent complete. So you'll have a projected rate based on your baselines and your estimates and some completion rates, and you'll have what is actually happening. And typically with an earned value, you'll do straight line projections. And you'll see, oh, our MVCR release is showing late. We planned it here, it's going to be over here. That's not good. We have a slip. That slip we expect to keep projecting because nothing else is going to change. You can do some hand calculations on this, and you can do some pivot tables, all sorts of things we're seeing people do. But getting this information is actually non-trivial. There are some good tools in the market that help you get pieces of it, but pulling all the pieces together is hard. And there's not a whole lot of guidance today. Still, it does work. It's just manually intensive. On the other hand, it doesn't scale up well. As long as you have a single product or a single development pipeline, it's pretty straightforward. When you start going across pipelines or going across organizations, it gets more complicated. The kind of information you need to do this sort of thing, we typically would understand an earned value in terms of what are your baseline costs, what are your actual costs. These are usually in terms of schedule. A current way of thinking about these schedule things are in lead times. When did you start? When did you finish? How long did it take? There are a number of different ways of defining lead times. I'll show a few of those later, but typically you'll have something like the cycle time and the actual process. You've got times between when you put in a request and when it's actually delivered. You want to understand how fast work items are coming through the system. So you need to have some notion of throughput. You have to have an understanding of what is the resource you have available to do this work, things like the staff hours. And we shouldn't forget that you need, no matter what you are doing, you need some kind of notion of a roadmap or an integrated master plan that tells you what is my release schedule? How have we organized our strategy, and you need to decompose the work into manageable chunks. Now, what's the next thing you could do here? Well, one of the things we've done in the past on my team is looked at things like the variations from the norm. We have estimates. Some things are bigger, some are smaller. They take different amounts of time than planned. And sometimes they take different times because you've had variations in the staffing. The work might be more complicated. There might be staffing limitations. Those sorts of things are typically a form of common cause variation, presuming you don't have a bias. If you do have a bias, you'll typically see it as a difference in a completion slope. But the variation at the individual level is what's happening with these individual components, some big, some small. And we've looked at those and we've done variations on actual versus applied effort and the effort required to build the components. And we noticed that they have very regular behaviors typically. They're typically like log normal distributions, and you can actually make some stochastic projections. So one of the things we were able to do in the past was take some of the historic data and do essentially a Monte Carlo based on the random variation as the work was actually completing. We were able to do these projections over time, and now you can see credible ranges over what is a reasonable expectation of completion. In this particular case, our completion date is way out there and it's got a fairly wide range. This is useful to know because it gives you better information than just a straight line. It tells you what are your sources of variation, and it gives you a credible range. Like you can say, is this date out here longer than I can tolerate? If this range of dates are outside of your tolerance range, then you have to do something differently. So now you need something like a what if scenario. Well, let me make sure I got the right one there. There we go. Wrong. Yes, here's the right direction. So in this scenario, we took the same sample project and we made some different assumptions about the applied effort. So we said, at this point, we're going to be able to add some additional resource. We're going to split the work up. We're going to add an extra team. And it's going to take a little time to come on board, but once they start going, we're going to be completing at new rates. We're still going to have some variation, but the stochastic variation is going to bring us into this range. So based on this Monte Carlo scenario, we can bring our dates in. Now, you still need to understand what is the sequencing of the work. You need some things like what is the total amount of work that you have within this current plan? What is the logical sequencing? What is my release plan? What do I expect to have done by these key dates? You need to understand what are the variations in the different types of lead times and other factors. But when you have these in hand, you can do some credible estimates. So what our project is aiming to do is collect some of the underlying data to support this sort of analysis in more or less real time. Now, this gets interesting as you move into the multiple pipeline scenario. This is just a notional example of a DoD type of system where you have contractors and subcontractors, you have integrations. So you have different pipelines developing different components. The components have to come together at different merge points. Don't pay too much attention to the specific topology here, but the notion is that you will have several stages where you're actually waiting on something. And you have these different pipelines that have to integrate and come together, and you're not really done until you get all the way over here. So we're in the process now of doing some analysis on this type of problem. And our work so far has been simulating. So we've been using some simulations based on data from typical projects, but synthesized and using a fictitious fake project, if you will. In this particular one, we have a totally fictitious project that is going to have a main development line. It's going to have some encryption hardware and antenna. It's not based on any real project. It's just similar to some others that we've seen. The important points is that we have 3 threads of development. We have an antenna group, we have a main development, we have the encryption hardware. They operate independently until they come to these merge points. The encryption group has to merge in with the main development. The antenna group has to come in with main development here and here. Okay, that's simple enough. What's kind of interesting is once you start looking at the problem, you realize a lot of the things that we've been trying to do in the DevSecOps world don't really make a lot of sense anymore. If you think about how flow metrics work or Little's law, a lot of the assumptions are violated because you don't have the single entry points. You don't have the same type of consistency in the flow. And what's worse, you don't have some of the other you don't have models for some of the other problems, like what is the handoff time here? How long, what's the latency between getting the work from this encryption team to the main development? Are they even in the same organization? What if you have to send something back, heaven forbid? If you have a problem here and you have to send work back, how are you going to include that in your models? Now, we're looking at things like that, trying to understand what are the different lead times involved. So we have backward leads, we have pipeline to pipeline transfers, we have different integrations. But the point is, you're trying to build to a certain product. And these are things that we have done some simulations on. And our initial work has shown that, in principle, we should be able to do this with something like a network Monte Carlo. We have a network Monte Carlo looks superficially like a PERT chart, except instead of using a PERT distribution, you use some sort of empirically derived parametric form for the efforts. In this case, we used a parameterized effort distribution for the components that were going into these builds. And we were able to compute a hypothetical frequency distribution for what's our end date. In this case, we looked at the merge date for encryption hardware into the main line. What's the merge date frequency? And we said, well, the mean and the median are all pretty close, but look at this range. We've got essentially a 30-day range between the earliest possible date and the latest possible date. And this is basically a last horse across the finish line date. Everything up to here has to go into 5. Everything here, 1 through 3, has to be done before you can merge. So you aren't done until both of these trains of work are fully complete. And that's one of the problems when you get into these multi-pipeline scenarios. There are ways of trying to finesse this. You see things like in SAFE where they have the train metaphor and the trains leave full. That's great, and that keeps you running, but it isn't going to help you get a specific capability, because you don't get that capability until all the features that go into the capability are done. So what do you need? You need a lot of data from the DevSecOps pipeline. So I'm going to discuss a little bit about how we propose to obtain that data, a little bit about how to store it. What we need are things like time-based effort and variation for things like to get things like production rates. There might be some different types of work involved, new development versus rework versus security and bug fixing. That's why we want to do some segmenting by primary work, rework. You want to understand some things about the defect rates. But essentially, you need to get things like timestamps, know what type of work is being done, where the effort is going, and where are the real bottlenecks. So I'm going to describe the measurement approach in the next few slides. This is a high-level ConOps. And the ConOps is showing several parts. Overarching, we have some management system. These are typically done with Jira or a GitLab, something that is managing the tickets. Here we have essentially the work breakdown structure organized by a roadmap. All of these are the high level features before they've been decomposed into stories. High level features that define what is my MVP, what is my MVCR, what are the other releases. It's a release plan, and it's decomposed to things like a feature level. Everything's going to be changing, so we expect these are going to change over time. As we get into work, we're going to be pulling off items from this roadmap, decomposing them into stories, and they're going to individual pipelines. The pipeline is where there is a, now, before I go any further, getting data from something like Jira, GitLab, Rally, that's a pretty well-known problem. People have been doing that. The best practices that we've seen have maps that take the work items back to the roadmaps and the work breakdown structures. A very tedious manual operation, to be sure, but it has been done. As we move into things like the DSO pipeline, we have all sorts of new information that can come available. You see things like, when did the work start? You can get code commits. You can see where there were builds, where the builds were successful, when the builds were pushed out into deployment, or at least an initial stage delivery. You can often see cycles in the rework. I'll show you a little slide on that later. The point is, during the development, you get a lot of information over what's actually happening with these components. You could go back to your GitLab, for example, and see how much code was built or how many different modules were touched. Lots of potential information we could collect here at a very atomic level. And that can be mapped back to individual features and individual stories. And these capabilities ultimately are what we would like the estimation plans to be based on. As the work progresses, you have the telemetry, which is going to be gathered. There are some techniques for doing this, and this is where the work is really kind of a work in progress. There are some things that have been going on with the Platform One, for example. Longer story, I won't go into that now, but getting information is a work in progress. This is where a lot of the work has to be done to make sure we get the right information that is answering the right questions. But as you get the information, you have to store it. And that raises another problem. There's a lot of push today about having the data lake, the so-called data lake. And I prefer to think of most of these data lakes as the software measurement pools, or swamps, which means if you are really careful about how you put that data in there, how you record the context, how you record the relationships between the pieces of data, you end up with something that isn't terribly useful. It's just a swamp. So what we are advocating is going through some effort of transforming the data before you store it. You're not going to get just the raw data. You can have the raw data there, but you better do some serious transformation, because that's maybe 80–90% of the work of doing these sorts of analyses. When you have the data in good shape, you can take this to a monitoring system. And presuming that you have well-defined data, that you understand the context, that you have a good roadmap, now you can start putting together the types of charts that I was showing you in addition to others. You can understand, what is our percent complete? How are our rates progressing? Are we on track with our initial plan? Where are the variances? And what do we think are the root causes of the deviations? If we make some changes, what are the effects going to be? So let's dive a little bit more into the data. The approach that Platform One had been using, and we were borrowing, was to use a system that had been developed at Capital One called Hygeia. That's kind of on the way out for some technical reasons. The source code is old and they've got some issues with it. But the underlying concepts are still sound, where you would have different types of collectors. Collectors for the different types of tools involved, whether they're Jira, Fortify, Sonar, GitLab, any of these tools. Prometheus. These collectors would actually transmit the data, and then you have to store them in some sort of database. Hygeia was using a Mongo database, for example. We had developed our own database that was in a warehouse form. But this is going to have essentially the events. What happened during the builds? What happened during a static analysis? You can think of looking at issues like how frequently what was the frequency of your builds? You can derive how many times did it take a build before it was successful? How long was it between successful builds? Things like that. And one of the things we've done with this is to make it a little more approachable. We have done some samples of actual pipelines where we have the tools and we put together sequence diagrams. Here's the actual sequence diagram of operations in a hypothetical example. So you have the GitLab talking to a Jenkins. The code goes into a Sonar Cube for testing. Did it pass or fail? It has to pass eventually, but how long did that take? Then you're going to go through the build cycle. As you go through the build, you can be watching things like the Kubernetes manifest. Eventually, you get a build complete, and it gets pushed out through an apply and a commit. So you can see through the sequence diagram a lot of the different scenarios as work passes through the system, and you can start to perform different types of analyses to answer different questions. Our primary question going in is going to be about how long it's taking to get these things built. But there are all sorts of other things that you can now potentially address by automating the data collection in this system. Step back a little bit and show you some additional lead times. Because you have a fairly a robust and precise system, you can now get some of these lead times with some precision. And these would be, how long did it take between something going into the issue tracker and being deployed? How long did it sit in the backlog? Once it entered the pipeline, how long did it take to get through? How long did it actually take to get from code to code complete, from code complete to build? How long does it take to get enter the system to exit? You can define these things precisely and rigorously because you can define the workflow through a DevSecOps pipeline. One of the things I particularly like about the DevSecOps is it's made process respectable again. Now, information that could be of particular use to this community. As we collect information on these features, as long as you are if you are really serious about tracking progress, you have to do a proper decomposition. Well, in some sense, the aggregate is just the sum of the parts. As we have these individual stories roll up into features. These features roll up into capabilities. So we have potentially here a mechanism for tracking at a very granular level how much effort really did go into these features. Potentially, we can do some other calculations on these features as well, whether it's a number of modules touched, whether it's the lines of code. Perhaps we can do some backfiring of some sort on a function point analysis. But we potentially have some automatically recorded insight into the capabilities and the work that actually goes into them. There's also the opportunity to look at other information, like how much of this work was in the form of rework stories, how much of this work was in dealing with security. Because we're tracking this with some precision and we're going to the effort of of labeling the work as it's being done, this can be collected automatically, and we can write the algorithms to analyze and display the information. Potentially, this could be very powerful for future estimation where we need to find reference classes for things like capabilities. This is just some more details. The example I was showing you was how we would propose to do something like a % complete. Where are we today? As long as you have these individual pieces, you know how much you planned for them. You can say, what did it actually take? You can say in an earned value type of sense, what did it take? The math for doing earned value or earned schedule, if you prefer the Lipke, which I do, is well defined. We know how to do it. It's just a matter of transferring it into this particular language. Now, challenges in the multi-pipeline world. Well, first of all, we found fairly early on that you can't just use the pipelines. There's a lot of surrounding tools, especially the issue trackers like GitLab and Jira, that are managing the tasking. In the multi-pipeline world, that's even worse because these management tools are often distributed across different companies. So you have to have some rules of engagement for how you do the definitions and how you aggregate the data. You do need a front end of some sort that's going to be able to talk to the different tools and gather information, gather the data in predictable, consistent ways. And you do have the problem that some of these tools still have humans in the loop for certain parts, like entering data into GitLab or Jira. We found that there are still confounders that are tricky to measure. These confounders may or may not be visible. So that's something we have to be aware of long term. A good example is how much staff time is actually available. Unless you have hooks into the financial systems or even the actual day-to-day record, it can be hard to know with any precision how many people really were working. There may be some other ways that we can see that that I don't want to go into right now, but that's going to have to be a work in progress. Different pipelines can, in principle, have different iteration cadences. If you have a single factory, you usually have some structure in place where you can control this, but that may not be the case as you move into the multi-pipeline environments across organizations that we see a lot in the DoD world. And there's some work to do on how to gather contextual information. One of the things we found with the high-powered tools like Jira and GitLab is they were not designed for these types of problems, and the standard data fields don't support them directly. Now, there are ways you can do it, but you have to be very precise in how you set up things like how to use labels or how do you do the structuring. So the rules of how we would use these different tools are still a work in progress. We have some approaches using things like labels with GitLab that help us work through this, but we have to figure out how extensible that would be and how amenable the different tools are going to be to working in a consistent way. This comes into issues like if you have to separate primary work from rework. We found that setting up a good labeling structure is non-trivial, and it's unlikely that if you have a system in place that it's going to be very easy to make some substantial changes. That is, you're probably going to have to do some work from the ground up in structuring your GitLab or your Jira to use this kind of approach. Some other observations. The tools, by and large today, are pretty siloed. They weren't intended to work together for the purposes of data gathering. You see this in some of the aggregation tools, and there are some commercial tools that do the aggregations, but they typically make some different assumptions, and they don't all see the same things. That's why we're trying to understand what we can do and do consistently. We are, by the way, talking with some of the vendors and are in the process of having some of these discussions. Observations about the data. A lot of the data metrics that you see in the literature that are recommended to collect are useful for some purposes, but not for others. We see a lot of averages, for example. Okay, well, averages are fine, but they don't really tell you about statistical modeling. With averages, you're not going to do these Monte Carlos and get real projections. What's worse, an average isn't going to tell me how long it's going to take me to get a high priority fix in. You need to know what is the capability of doing something if I move it to the top of the stack. In principle, you could get that if you had averages with the right categorization, but we don't see those in any of the in any of the guidance. So there's a lot of work to be done in making practical guidance for what you should collect, getting distributions instead of just averages, and specifying what are you really trying to accomplish with these individual types of data. We do need to get more specific lead times. There are multiple if you say lead time, there are at least 3 or 4 different ways that people are going to think about what you meant. And that's for a good reason. The different lead times have different application for different questions. So just defining the questions you're trying to answer before you go directly to the data that's supporting it is going to be something that is needed. That is, you need to start with what are the questions you need to answer? What data do I need to answer these questions? The automated timestamps will be very useful was one of our observations, and that we have to have additional categorization for the types of work being performed. Like, is this new work that is directly engaging the product? Is this bug fixing, which is just rework? The worst case scenarios with some of the earned value approaches we've seen is people getting credit multiple times for fixing the same bug. And that the flow metrics typically don't really apply if you're trying to look at a gestalt of these overall projects, because you don't have single points of input. You have these merges. So the things that you would typically try to do with Little's law or flow metrics don't really apply because you're violating the assumptions a little too strongly. So with that, I'll say that this is a work in progress. We've made a lot of progress so far. There's a lot of technical work to be done, but we have some basic things in place right now, and we're looking for collaborators. If anyone is interested in trying to apply some of these approaches and helping us understand what really works for you, we would love to talk to you. So I'll have my contact information at the end of this, and be glad to talk about any questions, where we are right now and what we're trying to accomplish. We'll have some short descriptions available of where we are right now, what are the approaches, what we're looking for, and if you think you might want to try out some of these approaches, what are kind of the entry conditions? What do you think you would need? What do we think you'll need? And with that, I want to thank you very much. I hope I made that in time. That doesn't look too bad.
Oh, you did
Oh,
great.
sorry, these are some background slides. Back up. There we go. Okay.
Thank you so much. Do we have any questions?
Hey, Bill, it's Brad.
I have a question, another question or a comment. I just want to thank you for the presentation. I really liked it, and it's very dear to my heart that it's the automated collection of features and data for is actively going, because I used to do some of that as part of my PhD, and I do know for sure firsthand that adjusting those issue trackers to for the process and proper labeling, it could be a hassle. Yeah, it's definitely was a challenge when I tried to use that. I tried to use issue trackers for data collection in both one of the industry projects and in 577 software engineering class for students projects.
It is a challenge, isn't it? We did a project a few years ago, and even within the same company, there were so many different ways they used the same issue tracker that it was like a Tower of Babel.
Yeah, that's true.
I'm sorry, I'm not seeing the comments right now. The Zoom has done something funny to me, and it's hidden the chat window.
That was Alexei Tregyubov that was speaking just now. And I think, Brad, I think you had a question?
Yes, Bill, this is Brad Clark. Nice presentation. I was just wondering, this seems the DevSecOps seems to be kind of in a nascent stage of becoming an efficient way of producing software. And I was wondering, I mean, this is a little bit off topic, but do you think this will eventually make it in software engineering courses where this type of pipeline, continuous integration, continuous delivery, along with bottlenecks, how to resolve those, measuring, cost estimation, those kinds of things? Do you think that would be a good thing for future, like master's courses in software engineering?
I think that would be a great thing. Yeah. Back in my TSP days when I worked with Watts, we had thought through a lot of these issues on how you would measure a software project and how you would do things. But I think part of the reason it never got broadly distributed was it was so much work. You had to do so much by hand. And when you look at a DevSecOps pipeline, one of the things that really jumps out at me is, oh, you have defined your development pipeline. At least the construction portion is actually well defined. If I can build this pipeline, I could basically write an algorithm for saying what was the process. Oh, process is allowed again.
Right. I like the processes. It's instituted into the whole concept. I like that idea.
Yes, it has brought process back into the vocabulary, and it's made it respectable again. After a decade or 2 decades of being pushed to the side, people have come back to the process idea, because if you're going to make things efficient, you need a process. If you want things to be reproducible, you need a process.
Right.
A process
totally
gives you
agree.
that basis for improving things, and it gives you some predictability and consistency.
Excellent. Thank you, Bill.
So we have a comment in there from Joanne Lane. Some great ideas / concepts. We've investigated introducing many of these concepts into the SDSU CS curriculum, but have been delayed due to campus shutdown during COVID.
Oh, that's unfortunate. Love to see if you're making any progress. If you please send me the comments when we're done. For some reason, Zoom has disappeared the window that lets me see comments.
No
I
worries.
think there's a lot of opportunity. There's a lot of opportunity here. And one of the big bottlenecks is actually being able to get working projects that can share data. Everyone, I think, is familiar with the issues of sharing data in the commercial world. It can be even more challenging in the DoD world. We're dealing with both the government and the contractors.
Yeah, Bill, I think you've done a great job at laying out what the challenges are. Really appreciate this presentation.
Well, thank you.
This is Joanne Lane, and I'll keep you posted if we start making some progress out at SDSU. I'm basically retired, but I work on special projects with the department still. I'm trying to get some of these major big projects going that our graduate students can work on as part of their research work.
Well, that'd be great. And if I had one piece of unsolicited advice to offer, it's always start with the questions you want to answer. I think part of the reason we see this zoo of metrics out there is people try to come up with all of these different things that they might find interesting or that they can collect. And they lose the picture of what is it we really need to know? What are the real problems we need to help control our projects and programs?
Agree totally.
I'll second that.
Right.
And
Last
I think
question.
I would, if I had one other comment here, it's that I can foresee if we can make this work, there is an enormous opportunity for using this in the estimation world. This everything begins in tracking begins with estimation. We're looking at the tracking side, but if this data is available, there could be an enormous benefit to improving how we estimate these projects in the first place.
Okay, it looks like there's one last comment. SEI goal-driven measurement. That was a comment from Ray Maddocky at NPS.
Absolutely. Uh, I strongly I strongly advocate the goal-driven measurement. Always begin with your goal in mind. What information do I need to achieve that goal?
Well, I'll just add that that fits right into practical software measurement. Same approach. You know,
Absolutely.
what do you want to know, kind of thing. Yeah.
Absolutely. A lot of this is heavily influenced by the PSM, and I hope that we can. I hope that as time moves on, we can start to migrate some of this into the practical software measurement, because that's really the objective here: making the measurement more approachable, more practical, and more useful for our stakeholders.
Awesome.
All righty, thank you so much.
Well, you're very welcome, and thank you for having me here.